So first we have Adam Atkinson.
On screen at the moment we have the results of an informal literature survey that Rachel Traylor, who tweets as Mathpocalypse, and myself carried out on textbooks at a sort of high school to early-ish undergraduate level from the 1930s through to the present day on a particular topic. By far the most common level of coverage was nothing, but we were amused by specifically stating that they weren't going to tell you anything about the topic, possibly by saying it's contrived so we won't, or it doesn't turn up in applications so we won't. In some cases they said if you have to know, look at this other book. Sometimes they describe it but not give you any examples, and if they did give any examples it was one and always the same one. So the natural question is, are there any others and what do they look like, and why do people not want to tell you about this? Down. Damn it. Space, yeah, good idea. Right. Well,
Adam's got a lot of text.
sorry.
Turn it off and on again. It's conspiracy.
Okay. It's not necessarily silence. There's also elements of vagueness and dark hinting in the whole phenomenon. I'm Adam Atkinson from ELHP. We have a logo now. I'm considering getting some sort of motto, maybe Habemus Logam, or whatever the Latin for we have a logo would be. So you may or may not have come across discrete probability distributions, something like throwing a die, divide the result by 6, you get 6 possible values between 0 and 1, and there are exactly 6 values that can turn up. They have positive probabilities. This has something called a probability mass function, and there are various famous ones. And that would look like this. So you've got 6 points that have actual values and everything else is 0. And the cumulative distribution function version of that, probability of being less than or equal to some value, has what we call jumpy bits in form of mathematical contexts in it. And between those, we have flat bits. The alternative kind of probability distribution that you do at high school and early undergraduate are called continuous distributions. Say we have a spinner that we spin and it chooses random numbers between 0 and 1 uniformly. This has a thing called a density function, which in this case is the same value everywhere, but it's positive everywhere. And the cumulative version of that is a sort of slope type thing, which has a feature we would call slopey bits, in line with the former terminology. Now, we could combine the two and say, I'm going to throw a fair coin, and if it comes up heads, I'll choose a value from the discrete distribution, and if it turns up tails, I'll take one from the continuous distribution, and the result of all of this isn't either. It doesn't have a mass function, it doesn't have a density function, but it still has a cumulative distribution function, which has both jumpy and slopey bits, using the terminology we've been sticking to. But this isn't the conspiracy. You don't tend to see this much in examples either, but that's just mixing two things we know. That's not very mathsjam. There is a third basic kind of distribution that almost nobody bothers to tell you about. Instead of having jumps and slopes, let's not have either of them. Now, Rachel and I think that the best name for these would be red-headed step distributions, but apparently that's not what they're called. Distributions from beyond space and time, probability distributions of the third kind. No, they're called singular distributions. Who has ever actually done these here? Blimey. Let's have a non-contrived, perfectly realistic, everyday kind of way of creating one. Throw a coin infinitely often, and if on the nth throw you get heads, award yourself 2/3 to the n pounds, and you get the sum of these values for all of the times you get heads. What does the distribution of your possible earnings look like when you do this? It doesn't have a mass or a density, but the cumulative distribution function looks like that, which, I don't know, can you see that? Just about, oh, how do I move this? I've got a video of it. Is that visible? So it's a member of this whole family of similarly contrived distributions. And this is called the Cantor distribution, and it's the example that you get in books if they bother to give you one at all. But this is mathsjam. You're thinking, honestly, I'm not that excited anymore. I saw that several seconds ago. It's got flat bits and it's got some jiggery pokery, but can they be worse than that? Yes, they can be. Have a look at that. That is called the bubbled play distribution, and I've got a video of that too. How do I get rid of that? Anyway, I mean, You're missing the right bit right at the bottom. Is this sufficiently unpleasant looking? This as the cumulative distribution function of a probability distribution. This has derivative 0 almost everywhere, is continuous, and is strictly increasing. How do you calculate the mean and variance of beasts like these? Thank you very much.